Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and we are now going to our last section of work, which is specifically about Euclidean geometry. So when we talk about Euclidean geometry, it's actually a very, how can I put it? It's a very difficult part of the exam, but it is actually very doable. So when we talk about Euclidean geometry, I must first do a dum. This is only part 1 of 3. Okay, we have divided every question into a part, okay, or the 3 questions each having their own part. And in this one, we're going to start by focusing on some theory. Okay, so when we look at this question 9.1, it says here, copy and complete the statements below. First of all, the opposite angles of a cyclic quadrilateral are, drum roll please, supplementary. Then the angle between a tangent and a chord. Now this one is a bit of a doozy to write out, but it is equal to the angle between the 2 chords in the opposite circle segment. Okay, so it's again, there's a lot of, this is just theory, guys. This is just theory. Then we get to question 9.2, which is also theory, because it says there BAT is a tangent to the circle O. Use the sketch and prove the theorem. There's a very important word there. So in other words, it's not something you need to figure out. It's something you actually had to study beforehand, and therefore there's a standard way of doing a formal proof. So in this case, ladies and gentlemen, we are always going to start with our sketch and write out the 4 parts of the sum. So the first one is what is given. What do I need to prove? Then there's going to be the construction. And then, last but not least, is the actual proof. Okay, so the actual proof. So let's start with what was given. What was given is you've got a circle with center O, and you've got a tangent BAT. Okay, what do I need to prove? I need to prove that angle BAS is equal to angle D. Now, what construction is necessary? The way that I chose to do it is actually different from the way that they did it in the memo. So I'm going to show you my method. You can also go and have a look at the memo that is available on the Junior Tikkie online website, and they do it in a completely different way. So what my construction is, I'm going to construct the diameter AR, okay, and connect RS. Of course, for me to do this, I also label the angles in a specific way, just to make life easier. When I look at this now, ladies and gentlemen, I'm going to start by what do I know when I've got a circle and a radius. A circle and a radius. Oh my goodness, where's my mind? I mean a radius and a tangent. First of all, angle A1 is 90 degrees because there's a radius that's perpendicular to the tangent. Next up, because I've got a diameter, angle S1 is also 90 degrees because of angles in a semicircle. Last, not last, what we are trying to do now, or what I'm trying to do, is get a value for the angle R, or an expression for the angle R. So I'm looking at the interior angles of the triangle, and therefore angle R is 90 degrees minus angle A2. Now, what does angle R have to do with D? If you look carefully, angle D is a cyclic quadrilateral. So in other words, I can say that angle D is equal to 180 degrees minus angle R, because the opposite angles of a cyclic quad is supplementary or are supplementary. So angle D is 90 minus A2, because remember we got R to be 90 minus A2 down there. Next up, I'm going to simplify this and say that angle D is then 180 minus 90, which is 90. A minus times by minus is a plus. So angle D is actually 90 plus A2. But now I'm going to do a bit of a sneaky. What do I know about angle A1? Well, angle A1 is 90. So in the place of the 90, I'm going to put A1. So in other words, angle D is actually A1 plus A2, which then tells me that angle D is actually equal to angle BAS. And there I've proven the theorem that of the tan chord. Whoa, I love this. I love the theory, because now you can use the tan chord theorem without a question. Now let's look at the question that is not theoretical based, or that's not a theorem, let me rather put that. So let's look at this next question. So the next question is, PQR is a tangent to the circle, EF is parallel to QH, and then they're giving you that. I'm going to ask you, hit the pause button, try the sum yourself, and then we'll take it further from there. So when we look at this, ladies and gents, your approach is crucial. Number one, we start by mining. So we dig into the information. So they tell me PQR is a tangent. So first of all, I can think about theorem 7, which is tangent perpendicular to radius. Or I can think about theorem 8, which is two tangents from the same point. Or I can think about theorem 9, which is the tan chord theorem. Now I know that I don't have a center. I'm looking ahead at the sum. I don't have a center. So theorem 7 is out. I don't have two tangents, so theorem 8 is out. Next up, I'm only left with theorem 9. So in other words, Q3 is equal to angle E2. Also looking at it from P side, I can say that Q1 is equal to H3. And writing that on the sketch, you'll see what I do there at the top. Underneath the 9, I put the circle and the X, because that just tells me going forward, I know which theorems I used for the circle and the X. So I'm going to write that in on my sketch for future reference. Next up, they tell me, or I can calculate actually angle Q2 by either going interior angles of a triangle or angles on a straight line, whichever one works. Last in this, or not actually last, second last, I'm going to go towards the parallel lines. So I could use either F, U, or N. Now there isn't an F in here, but there's definitely an N. You will see I kind of stay away from the U. Not because it's wrong, but just because, I don't necessarily like to work with angles adding up to 180 degrees and those things. So I'm going to use the N, and get that E1 is equal to H3. So putting it under the N, there's that little circle. Now I know what I have used. Last bit of information is that FG is equal to GH. Now, it's a bit unclear on my sketch, but I'm now saying that F2 is also H1. Why is that? Because of an isosceles triangle. Sure, a lot of information. And can I now move on to the question? No, don't. What about cyclic quadrilaterals? When I look at cyclic quads, I actually have got two of them. But the theorems that I can use is the bow tie, the opposite angles being supplementary, or the exterior angles of the cyclic quad. So in the first cyclic quad, I could say that in that cyclic quad EF HQ, that angle F1 is 100 degrees. Or, looking in the other cyclic quad, which is the smaller one, there that I highlighted there, EFGH, I can also use to calculate angle G by using opposite angles of a cyclic quad. Okay? Now, you'll see that E1 and G is related by using opposite angles of a cyclic quad. Let's start with the first question, because now I'm actually going to go over to this question. What do I know about Q1? Oh, but sir, Q1 is 70 degrees because of tan chord. Ta-da! 2 marks. I now have to get to angle G. But which angle does G relate to? G relates to E1. So I must first of all get E1. But to which angle does E1 relate to? That relates to H3. So I'm going to first of all say that H3 is E1 because of alternate angles, because EF is parallel to HQ. Next up, angle G is 110 degrees because of opposite angles of a cyclic quadrilateral. As easy and straightforward as that. Now look at F1 and let's go for F1. So I'm going to do it on the side in that little block there, just so that we don't squash it at the bottom of this slide. If I look at angle F1, how did I get it to be 100? Well, I related this to Q, first of all, Q2. But Q1 I found by first getting E2. And E2 I got from Q3. So there I've laid out the whole plan that I've got to do. So first of all, I'm going to say Q3 is equal to E2 equal to 30 degrees because of tan chord theorem. Next up, Q2 relates to E2 because of interior angles of a triangle. Look, you could have gone angles on a straight line if you first wrote out Q1, which you actually did in 9.3.1. So it's a bit superfluous. That just means it's a bit over the top. It's extra. But this was my logic, so I'm going to run with it. Next up, F1 is then 100 degrees because of opposite angles of a cyclic quad. And there you have 10 marks, in total 18 marks for this question by actually doing very simple Euclidean geometry. Ladies and gents, I hope you enjoyed this video and you're going to take this knowledge into the next video where we're going to dig deeper into Euclidean geometry. So this is Mr. VG signing out. Have an amazing and wonderful evening. Keep well. Cheers.